Alright, in this video we're going to make the method called collisions or check collisions, and it's going to be almost fully functioning collision checking algorithm by the time we're done. So we would just want to do public, and then we're going to say Boolean because we want to be able to tell someone, yes, in fact, a collision has been detected. That's how I'm doing the system anyway. So we're going to call it check collisions. And this method just needs to take in a rectangle, R. So the game panel class will send over rectangles which represent the object that we want to check against. So we'll just put return false here at the time being. Actually, let's not do that. So let's set up a Boolean to be our return statement. Boolean collision detected equals false. And then let's return collision detected down here. So we'll give back the answer. So unless we find a collision, it'll return false. Alright, so what do we need to do to check these collisions? Well, like I said in the intro video, we're going to check it in the X direction first and then in the Y direction so that we can tell if it has bumped into a ceiling or a floor, or if it has bumped into a wall left or right. And we can make choices based on that. We can flip the appropriate velocities. Because if we only can tell the overlap, we can't really make appropriate choices regarding the velocity, and our game won't look quite right. So we need to grab the X destination, which represents the current X position plus the velocity in the X direction. And the same thing for the Y destination. Y destination equals Y plus dy. We also just want to set the values of X temp to X. I'm not 100% sure that I couldn't clean this up and get rid of these temps, but let's just do it this way because I know it works right now. And then we're going to start by checking in the horizontal direction. So we're going to check in the horizontal collisions. So this is going to use the X destination and the current Y position so that we can tell if a collision is detected in the horizontal direction. So we say calculate corners. We're going to use that method that we just created, calculate corners. And we're going to pass it over the X destination, not the current X position, but the future X position. We're going to pass over Y, and we're going to pass over R. So we say, like, we want to check all the corners of this rectangle. We want to do it based on our current Y position and our future X position. And then what this method does is sets the values of top left, top right, bottom left, and bottom right to tell you, okay, in fact, collisions have taken place with these corners. So you can imagine now if we detect that in the X direction, if we have hit something on the left side, we need to do certain things. So if top left or bottom left, we have detected, oh, I'm sorry, we can't do this quite yet. So we have to say, like, if dx, if we're traveling into the right, how about let's do the right. If dx is greater than 0, so that means we're heading to the right. So if we're going to the right, and if we detect a collision along the right-hand side of our shape, which is the top right and bottom right corner. So if we find that our top right corner has collided with something or our bottom right corner has collided with something, we want to flip the value of dx. We want to set the value of collision detected to true, and we want to set the x temp to 1 to the left of the box that we have collided with, because we're traveling to the right, and so it's like we and we bump something, so we want to set the x position to be less than that collision we detected. So let's say it equals r, the rectangle, dot get min x minus the size of the ball. And so now we need to continue checking. So we have to say, like, now we'll say if dx is less than 0, so we're going to the left. Then if we encounter a collision on the top left or a collision on the bottom left, then we need to flip the value of dx. Dx equals negative dx. Collision detected equals true, and xtemp now needs to be xtemp equals r.get maxx plus 1, and this really should be minus size minus 1 just to get it all the way off so we're not detecting multiple collisions. Okay, so that's the x direction. Now we're going to do the y direction. Same process exactly, but this time we send over the y destination and the current x position to calculate corners. So calculate corners, and we're going to this time use the x position, the y destination, and we're still going to check it against r. So we just need a semicolon. So now we are checking the future y position, and we need to do these same things if dy is greater. So if we're traveling down, we'll do certain things. So if dy is greater than 0, which means we're traveling down, then if we encounter a collision with the bottom, so if bottom right or bottom left has collided, then we need to flip the value of dy. We need to set the value of collision detected to true, and we need to set the y position, so y temp equals, let's see, if we hit the bottom, so we want to go up from the minimum y, so r.getMin y, not max, min y, and we want to say minus the size minus 1. So we pull up, yeah, I think this is right. Yep. And then, well, we may have to tweak this because I'm just kind of doing this quickly, but if dy is less than 0, so that means it's traveling up, so if top right or top left, if either of those two corners collide, we want to set the value, flip the value of dy. We want to set the value of collision detected to true, and we want to set the value of y temp to equals, so it's hit the bottom, so r.getMaxY plus 1, so one further down than that. And finally, we're returning collision detected. And then finally, we're going to have a little method called setPosition, which actually takes these temporary values and places them in our final x and y containers. But we'll do that in the next video.